Every year, 300,000 Americans who have missing fingers or partial palms due to congenital defects or work accidents enter the market for a new prosthetic hand. Currently, prosthetics are pretty expensive, with a purely cosmetic, non-functional arm being about $5,000 and a basic, non-realistic looking but functional prosthetic arm being about $10,000. Although both of these prostheses give the user some functionality of their hand by either returning aesthetic normalcy or very basic grasping capability, they are still limited. Even the $10,000 device, which allows the user to open and close a simple hook, only provides the patient with very crude usability because the user doesn't get any sensory feedback. This makes it very hard to handle delicate objects like eggs or flower buds without destroying them, and makes the users unable to perform tasks that would be easy for an able-bodied person. For example, it would be just as difficult for a prosthesis user to hold a tomato without bursting it, or give someone a handshake without painfully clenching their hand, as it would be for you to pick up a needle off a table while wearing mittens. Enable is an organization that publishes designs for 3D printed prostheses, which helps resolve the cost and accessibility issues associated with traditional prosthetic devices. This also caters to populations that need to switch out their prosthetic device relatively often, like children and adolescents. This still doesn't provide the user with feedback on objects that they're interacting with, so usability of these devices, although improved, is still not ideal.
This is the Haptax, a modular sensor incorporated into various prosthetic hands such as Enable's Raptor Reloaded. It costs under $200 to produce the sensors, electronics, and prosthesis itself, making it a cheap alternative that can be updated often as some patients such as children grow. Because it is 3D printed, it can be scaled to any size patient. Its plastic body makes it lightweight and easy to use. The silicone tips make the hand grippy, and the sensors inside tell patients how much force they are using, both of which help improve the patient's gripping capabilities. Overall, Haptax measures a pressure input and converts it to feedback, which is transmitted to the user's forearm via a haptic actuator. The pressure readings are obtained using pressure sensors embedded inside the fingertips of the thumb and pointer fingers. As the fingertip deforms, the pressure inside increases. That change in pressure is relayed to the microcontroller attached to the prosthesis. The data is transmitted via Bluetooth to the computer for software processing.
The software first allows the user to set up a profile consisting of their name and a threshold number. This value represents the maximum intensity of the vibrations to the user's forearm. The feedback provided to the user will be scaled so that the vibrations experienced when using the maximum threshold value as input correlates to the maximum possible pressure reading. The system processes the data based on the user-determined threshold value and a noise filtering component, and the system outputs the data via Bluetooth to the microcontroller. The microcontroller then controls a haptic actuator, vibrating depending on how great the pressure was. The more pressure is being transmitted, the greater the vibration. Thank you for watching our Haptax presentation.